Well, I thought I would try to put a little meat on the bones of the inhomogeneous systems by actually giving you a physical problem so we'd actually be able to solve a physical problem instead of just, demonstrate a solution method. So here's a mixing problem. So mixing problem. Just to illustrate what makes a system of equations inhomogeneous. So here are two ugly tanks. Okay, I'm not going to draw these carefully, but they are both 1 liter. Okay? And they're connected by pipes, and I won't bother opening holes in them. So there's a pipe, so fluid's flowing back there, and here, this direction, it's flowing this way. And, but that's not the end. The end is there are stuff coming in to both of them, and I think I'll just make it coming out of this one. There's something realistic. So, all right. Now it's perfect. So I'm going to put flow rates on these things. You could imagine, I don't know, some factory mixing chemicals or something like that, or 2 organs in the body which are exchanging blood for some reason, I don't know. Or, this is abstract. This is as far as I get with applications. Okay, so the numbers, 2, 3, 2. Let's start there and see what the others have to be. So these are flow rates. So 1 liter tanks. The flow rates are in, let's say, liters per hour. And I have some dissolved substance in. So here is going to be X salt in there and some same chemical in there, whatever it is. So X is the amount of salt, let's say. Salt in tank 1. And Y, the same thing in tank 2. Now, if you've got stuff flowing unequally this way, you must have balance. Otherwise, you have to make sure that neither tank is getting emptied or bursting and exploding. So what's flowing in? What's X? 3 is going out, 2 is coming in, so this has to be 1 in order that the tank X stay full and not explode. And how about Y? 2 going, 3 coming in. So how much is going out? 2 there and 2 here. 4 is going out, 3 is coming in, so this also has to be 1. Those are just the flow rates of water or the liquid that's coming in. Now, the only thing I'm going to specify is the concentration of what's coming in. So here, the concentration is 5e to the minus t. And that's what makes the problem inhomogeneous. Here, the concentration is going to be 0. In other words, pure water is flowing in here to create the liquid balance. Here, on the other hand, salt solution is flowing in, but with a steadily declining concentration. That's the sort of thing that would happen if a lot of things could, a lot of things create a declining concentration of a salt, but okay, a red herring. That's a red herring. Oh, let's not talk about it. Okay, so what's the system? What's the system? Well, it's you set it up exactly the way you did it when you studied first order equations. In other words, it's inflow minus outflow. So it's outflow. So it's the what's the outflow? The outflow is all in this pipe at 3. So the flow rates are liters per hour. 3 liters per hour flowing out. How much salt does that represent? Well, that times the so it's -3 times the concentration of salt. But the concentration, notice, the concentration of X, the concentration equals X divided by 1. In other words, X represents both the concentration and the amount. So I don't have to distinguish. If I had made it 2-liter tanks, then I would have had to divide this by 2. So I'm cheating, but it's enough already. Okay. X prime equals minus 3x. That's what's going out. What's coming in? Well, 2y is coming in. Concentration here, what's coming in is at y, 2 liters, plus what's coming in from the outside. So we have to add that in, and that will be plus 5e to the negative t. How about y? Y prime is changing because of what comes in from x. That's 3x. What goes out? Now, what goes out? Well, 2 is leaving here, and 2 is leaving here. It doesn't matter that they're going out through separate pipes. They're both going out. So it's minus 4, 2 and 2. How about the inhomogeneous term? Well, there's 1 coming in, but there is no salt in it, and therefore that is not changing. What's coming in through that pipe is necessary for the liquid balance, but it has no effect whatever. I'll put a 0 here, but of course you don't have to put that in. Okay, this is now an inhomogeneous system. So in other words, the system is X prime equals this matrix, negative 3, the same sort of stuff we always had, plus the inhomogeneous term, which is 5, the column vector, 5e to the minus t, and 0. It's the presence of this term that makes the system inhomogeneous, and what that corresponds to is this little closed system being attacked from the outside by these external pipes which are bringing salt in. Without those, of course, the balance would be all wrong. I'd have to change this to 3 and cut that out, I guess. But then it would be just a simple system, homogeneous system. It's these pipes that make it inhomogeneous.